Dear students, today we are going to talk about physical hazards, noise. As we discussed before, physical hazards are those hazards what we can measure. We have already talked about indoor climate, we have talked about lighting, and today we will discuss noise, vibration, and ionizing radiation. Noise has been a main health hazard in many industrial settings already for many years. And it has also been one of the main occupational hazards which causes occupational disease. We call this occupational disease noise-induced hearing impairment. In 2006, European Union adopted a directive which talks about noise and lowered the permissible level of noise in the working environment from 90 decibels to 87 decibels. Noise is a physical variable. We can describe it through sound pressure, through sound power, sound intensity, but also we can describe it by frequency, by duration, or sound pressure, intensity, and power level. When we usually think about noise, we are concerned about our hearing and the fact that noise can cause hearing impairment. But actually, it can also cause many other problems, physiological and psychological problems. For instance, noise can cause muscle strains. When the environment is very noisy, we usually take our muscles and keep them very strained. So it causes muscle strains. But it can also cause fatigue, headaches. It can increase our stress level. And at workplaces, it's very important to know that noise can disturb our communication or cause concentration problems. So what is noise? Is music noise? I would argue that music is not noise because we enjoy it. But when it gets very loud, then we can say that music is also noise, because then it becomes unwanted or uncomfortable. And noise is defined as unwanted or uncomfortable sound. Sound is produced by vibrating objects and reaches the listener ears as waves in the air or in the other media. And physiologically, noise is a perception in the air caused by mechanical vibrations. Vibrations hit the air. The vibrations set into the motion the eardrum and ossicles, which are hammer and the anvil. And the vibration there is changed into wave motion. It goes to the inner ear and will be sent to the brain by the sensory hair cells. Unfortunately, the hair cells are non-regenerative. It means that once they are damaged or destroyed, the hearing loss will occur because we cannot get any new hair cells. Here you can see healthy hair cells which can be active in many different frequencies. Human hair can perceive noise in the frequencies from 20 Hz to 20,000 Hz. And physical factor to measure noise is usually sound intensity level, which we measure in decibels. Noise-induced hearing loss can be caused by two different reasons. One is the short-term, extremely strong sound impulse. We call it as an acoustic trauma. It causes the problems with our eardrums. For instance, an explosion where the sound intensity level is very high, often more than 140 decibels, and usually it has a very short duration, like 0.2 seconds. The second cause is by long-term continuous or variable sound intensity level, which is around 85 to 90 to 100 decibels. And this causes disturbances in the metabolism of hair cells. Those cells degenerate and they are replaced with connective tissue which has no similar function as hair cells. The second cause is often the cause for occupational hearing impairment. Here in this picture you can see undamaged hair cells in the first photo and damaged hair cells in the second photo, where the person definitely has a hearing loss. When we think about noise types, then first by exposure duration, we can classify noise by sustained, impulse, explosive, and fragmental. Sustained is the noise level which is not changed during the particular period more than 3 decibels. Impulse noise, for instance, is a gunshot, is an explosion, so the sound significantly exceeds the background sound pressure level for a very short duration, usually less than 1 second. And it is with high peaks, like 140 decibels. Explosive is the similar one, and fragmental means periodical or aperiodical interval exposure. We can also classify noise by low frequency, intermediate frequency, and high frequency noise. Low frequency noise does not have a consistent definition, but they say that it's between 20 to 150 Hz. Intermediate noise is usually 800 Hz, and high frequency is everything about 800. And by nature of spectrum, we can classify noise tonal and homogeneous. Tonal means that noise is with distinct tones. For example, noise from compressors, noise from fans, and generally is far more annoying than other types of noise. But let's talk about low frequency noise and high frequency noise. We can say that the more rapid the change in the force, pressure, or speed, the more dominant is the high frequency noise. For instance, with a smooth gear design, the rounded teeth. The teeth fit more smoothly together and the force transfer is more continuous. And with this, the high frequency noise is lowered and more low frequency noise is produced. Also, the longer the interval between repetitions, the lower the frequency of noise is generated. When we think which noise, high frequency noise or low frequency noise is more dangerous for our ear, then it's usually said that high frequency noise is more damaging because hair cells are more sensitive in the high frequency noise level. But high frequency noise is highly directional and it's easier to reflect and therefore also to think about safety measures. The other good side high frequency noise has is that it's greatly reduced by passing through air. So with distance, it's decreased incredibly. We cannot say the same for the low frequency noise. So low frequency noise goes very, very far and you can hear it from a very long distance. When we talk about sound intensity levels, then we consider very quiet up to 30 decibels. This is a background noise, a natural noise, and we cannot lower it more. Quiet is up to 50 decibels, and it is said that human brain works very well when we talk about mental work, when the background noise is not more than 55 decibels. If it gets higher, we have more communication and concentration problems. For the ear, the most painful noise starts from the 120 decibels, but very loud is already from 90 and up, and there we start already the problems also with our hair cells. So as we discussed shortly before, we mainly consider noise as the main source for noise-induced hearing impairment. And as I said, the hair cells are more sensitive in high frequency range. So noise-induced hearing impairment first occurs in the high frequency range of 3000 to 6000 Hz. And it is important to remember that risk for noise-induced hearing impairment may increase when the noise exposure is combined with other exposure, such as exposure to vibration, but also the use of ototoxic drugs or other chemicals. Ototoxic chemicals are those chemicals which also impair our hearing. Then the second adverse health effect of noise is interference with speech communication. We can have problems with concentration. As said, noise can increase fatigue, but we can also get more irritated. It causes problems in human relations because we cannot speak with each other properly. We can have miscommunication. And based on that, we can also feel uncertain. We can have lack of self-confidence. And it can also cause decreased working capacity. Noise can also increase blood pressure, but usually it is only for those who are susceptible for it. It can cause hypertension and also ischemic heart disease. It can increase heart rate. Noise can also affect our mental health, especially for those people who have already problems with neurosis. It can develop it higher, and also it can develop irritability. And then the effects of noise on performance, which are very common. It affects the cognitive task performance, such as reading, problem solving, and attention. And as we cannot concentrate fully, it also can increase the number of errors. So let's go to the regulation. It is important to know that the EU directive has the exposure limit value of 87 decibels, but in many other countries, the norm for 8 hours is 85 decibels. This is also for Estonia. We can do noise measurements with different devices. We can do technical measures with sound level meter, but we can also do measurements with noise dosimeter, which is put to the ear, and the microphone is put to the ear, and we will measure the dose for the whole working day. You, with Sigrid in the practical classes, will do the technical noise measurements with sound level meter. There are several different noise mitigation measures. For instance, you can have a safety glass and exclosure with sound absorptive linings for around the machines. But you can also use different walls which are sound absorptives. And you can place the noise emitting source into different locations in the room in order to produce less noise. Types of hearing protectors. We can talk about earplugs and earmuffs. Earplugs are more for one-time use as earmuffs for the longer time. And it is important to remind that earmuffs and earplugs protect from noise only when you use them continuously. So this was about noise. Next lecture will be about vibration. Thank you for listening.